So in this short video, I want to give you a brief introduction to statistics. And this is for those who have not done statistics before. Statistics is about the study of information obtained from taking a sample and then using that information in the sample to learn something about the bigger population. So we have two terms that are mentioned here. One is called a sample and the other one is called a population. And let's see what we mean by those. So let's just look at condo prices. If we were to consider the prices of all of the possible condos in Halifax, we would call that our population. So, population, right, of condos. And so we could have different things that we're interested in. We could look at house prices. We could look at the time people spend commuting to work. And if everybody had a car, gave us information on that, then that would be our population. So there are phenomena in life that we have an interest in, and we want to understand it. However, the size and the scale or the scope of the information is so big that we cannot look at all parts of it. So with our population, we have things that we're interested in. And usually we're interested in things like the average, or what we call in statistics, the mean of the population, which in this case would be the mean of a condo price. What's the average condo price? So mean and average, let's say. Another thing that we're also interested in is a standard deviation, how much variation there is. So we are interested in variation, and we measure variation through something called standard deviation or variance. Variance, that's an R, and its relative is called standard deviation. Now we have symbols for those. If we're talking about the mean, the symbol is mu. If we're talking about variance, the symbol is sigma squared. And if we're talking about standard deviation, then the symbol is simply sigma. So you can see the relationship between variance and standard deviation, that the standard deviation is just the square root of the variance. So I want to just expand on these concepts for you and then introduce you to the normal distribution. Because for the most part in the course, we will refer to averages and standard deviations. All right? So in statistics, as I mentioned, we cannot study the entire population. So what we do is we take a sample, and that sample ought to be random so that there's no bias in how we select the values. And if that sample is truly random, then what happens is that we can claim that the sample is a representation of that population. So we randomly take a number. And that sample size we refer to as n. And then if we observe for that sample the average, then the sample mean is the term that we will use. We will denote that by x bar. So the sample mean is our best guess of the population mean. So one of the things that you will know about statistics then is that everything that we observe in a sample is an estimate of its corresponding parameter in the population. And then we have a sample variance, which is given by S squared. So therefore sample standard deviation would be S. All right? So you can see the relationship between S squared and sigma squared, or the relationship between mu and x bar. All right? So those are the relatives. Now I think most of us understand mean, the average, but then standard deviation, variance is a little bit different. So I'm going to go through those. So first one is the mean or the average. And the mean is just the sum of all of the values that we have. Now, to represent the values, if we don't have the actual figures, we use X to denote a value of the variable, whatever that we're interested in. So if there are 10,000 condos, our population would be X1, prices that is, X2, X3, X 10,000. That's all the prices. If we just put them all together, that's our data set. But if we want a sample, we take a random sample from that population, then we could have X1, X2, Xn. I notice n denotes our sample size. All right? So our sample mean will just be X bar is just the addition, that sign means the sum, the addition of X1, X2, right, to Xn, and then we divide it by the total number of values that we have. Now it's not proper to have the summation sign and put the plus sign as well. So we denote it by saying the sum of all these values that we have, xi we call them, I is equal to number 1 to n, and then we divide it by the sample size. So that's the sample mean. If we wanted the population mean, we do the same idea, but this time, since we have all the values, we denote it by capital N. And so population and sample. To get a really good estimate of the population mean, you need a good sample size, right? So keep that in mind as we go through. So I think most people, like I said, are cool with sample mean. Sample standard deviation is a little different. Another measure actually we often look at is the median. The median is the middle value. If we arrange all of the values in increasing value, in ascending order, and we pick that middle number, or the value between the two middle numbers, if it is even, an even set of numbers, then we have the median. So for example, let's just look at median before we go into standard deviation. If I had the following numbers, 4, 6, 9, 12, 13. So I have 5 numbers here. The median would just be 9. 9 is the middle number. It divides the data into 2 parts, right? So median is equal to 9. However, if I had an even set of values, so say I had 16, if I added 16 to this, then I have 6 numbers, so I must place the median in between those two. And I would average 9 and 12, which is 21, so 10 and a half. And my median would now be 10.5. What it tells us is that half of the numbers are above 10.5 and half of them are below 10.5. That's what the median actually does for us. Let us look at this concept of standard deviation, all right, and variance status. So what happens is that, let's say we have we have a sample size or population, either one, it's okay. Sample. Since we're dealing with statistics, we often work with samples. So x1, x2, x3, xn, and remember n is because that's number of samples that we have. So if I were to just plot this for just on a linear scale right here, if I determine the average, that's x bar, which is the sum of these values divided by the number that I have. Let's say x bar falls somewhere around here, x bar. So what would happen is that if I were to put all of these values, say x1 was here, x2 was here, x3, and so on, x4. So what variance measures for us is a measure of the spread in the data, how wide that information is actually spread. So I'm just going to let these lines denote where those values are. And so the way in which we look at it is we say, well, let us take the distance between the mean and those values and measure those, right? So you see, each of those gives us a sense of spread between the average and the respective values. So if I took x bar and I subtracted, each value, let's call it xi, and I subtracted from them x bar, I get that distance. Now, depending on if if the values here, x1, x2, for example, are smaller than the mean, the values will be negative. If they're larger than the mean, they'll be positive. So what we do to get rid of that is we take those values and we square them. So any negative differences become positive, any positive differences stays positive. So when we square these differences, remember those differences represent the distance from the average. If we add them all up and then we divide by the sample size minus 1, that gives us what we call sample variance, S squared. And the reason why it's squared is because if you look at here, you will see that we have a square, right? It's order 2. If we want the standard deviation, so standard deviation, this is variance, so standard deviation, S, would be the square root of S squared. And it would look something like this. It would be the square root of the sum of the xi minus x bar squared. Remember, that's all of the differences. And if I divide by n minus 1, that gives me s. So that really is just a measure for us of how far the values are away from the average. And the bigger s is, the bigger the amount of variation, the amount of spread in the data. So that measure is very important to us. If you're looking at stocks, the value of stocks, for example, if you have large standard deviations in the value of a stock, then it means that that stock is fairly volatile. So S measures the volatility for us. If the standard deviation is very small, that means that the values are very close to the average, and that's a fairly stable stock. All right, and the stocks that you tend to want to, depending on your risk level, if you're a big risk taker, you'll look at stocks that have large standard deviations. If you're not so big a risk taker, you will look at stock values that have smaller standard deviations. Okay, so that's variance and the average. So these are two important values that you'll hear me referring to quite a bit in operations management. Now that we understand a little bit about variance, standard deviation, and the mean, let's get to the normal distribution. We hear a lot about the normal distribution. So let's see what we could find out about the normal distribution. This is a table that we're going to need, so I'm going to come back to it very shortly. The normal distribution in statistics happens to be the most popular distribution. And what I mean by distribution, if I talk about distribution of salaries, I think we understand that. If I talk about distribution of, say, scores in a baseball, in terms of baseball games, essentially we're just talking about the values and how they actually occur in real space, all right, or real. So say batting scores could go anywhere from 0 to whatever it is. And so, house prices, we could talk about from $50,000 to $10 million. So that's the distribution. The distribution is the collection of all of the values. In a lot of cases, the normal distribution, and how you would know about it, is the bell-shaped curve. I'm sure you heard of the bell-shaped curve. Is very, very popular, and here's why. There are a number of phenomena in real life that come out a little squiggly here that can be modeled using this shape. So the average, it turns out that this distribution is such that the average for the distribution is right in the middle, and that distribution has a standard deviation. all distributions have a mean and standard deviation. If we're looking at processing times in a bank, there's an average processing time and there's a standard deviation of the processing time. If we're talking about commute times to work, there's an average and there's a standard deviation. If we're talking about snowfall, there's a mean and there's a standard deviation. So all distributions have that, and we usually just sort of label the normal distribution in this fashion. The normal distribution is what we call a continuous distribution, and the reason why it's continuous is because the values, if they vary on the x-axis, the values can go anywhere between negative infinity and positive infinity. Let's take, for example, we were looking at time as our variable. Well, if we count in nanoseconds, we could have an infinite number of possible values, and that's why we would have this continuous distribution. A discrete distribution, which you might have heard of, on the other hand, is when we have what we call a countable amount of values. In other words, the possibilities is actually finitely countable. That means we could count it. For example, if I say I was interested in how many times people actually go to the ATM in a week, well, we wouldn't say an infinite number. We would go between 0 and 10 times. So this is countable. All right? How many times people miss classes in a semester? Well, if there are 13 by 2, 26 classes, then it's finitely countable, between 0 and 26. Okay? And so we are concerned about the normal distribution, which is a continuous distribution. The reason why it's so popular is, as I said, there are many phenomena in real life that can be modeled by the normal distribution. For example, salaries. For salaries, we could have a distribution where a few people, okay, a few people make a lot of money. It's a small number right here. A few people, and you may disagree with me on that, make very little money, and the rest are sort of scattered in between here. So that's where most of us are. Another example could be, let's look at performance in grades, right? So if we look at the distribution of performance, and you often hear people talk about grading on the curve, there are some students who are just so good and so smart. They get the highest marks, above 90 and above. And there are a few students, hopefully a very small number, that will fail. And then the bulk of the students are somewhere in the middle. So you see, the normal distribution is very important. We could look at rainfall, annual rainfall. If we look at several years of rainfall, there may be a few years that had very high rainfall, a few years that had very little rainfall, and then the bulk is somewhere in the middle. So just name it, a lot of possibilities with this distribution. All right.